All right, good morning, everybody. Today is Wednesday, I think August 21st. And I'm not there, so here is the lesson for today. So first of all, we always start off and we do the Nearpod. Well, I'm not going to be there to discuss it, but I'm going to go ahead and share the Nearpod screen here so that you can see. Here is the code right up here at the top. B4, Q is in Queen, A is in Amy or awesome. 3, go ahead and take about 5-10 minutes and put your current event up there. I will take a screenshot of it at around 9 o'clock. I'll take a screenshot of those of you that have posted, and I will take care of your stamps tomorrow. Also, if you have a Gallatin shirt on, please just take a selfie. Take a picture. You can take it with your iPhone and just email it to me. My email is up there above the board, amy.edwards@sumnerschools.org. And again, I will make sure you get that stamp because I want to make sure, even if I'm not there, you're getting your extra credit. Okay, so now let's go on ahead. If you need to pause it for the Nearpod, go ahead. But now I'm going to go on ahead and go to the lesson for today, because today you have 1.6 and we've got 1.6 here, and then you're going to work on the 1.6 assignment in Achieve in your iPad. If you do not have an iPad, ask the substitute to please write your name down, because that means you're not prepared for class. And there is a Chromebook cart in Mr. Williams' room, so you'll need to go to Mr. Williams' room next door and get a Chromebook. So 1.6, we are going to talk about measuring center, and we have been talking about measuring center. What's the median? And so far we've been doing a little bit of guessing, or we've been doing some where we've been putting it through the Statmatic applet and it's actually been giving us the median. So we're going to kind of hone in on that a little bit and focus a little more. So our I can statements, you should be able to say, I can find and interpret the median of the distribution of quantitative data. So we're really going to dive into using that Statmatic applet. You should be able to say, I can calculate the mean of a distribution of quantitative data. Now, the mean is take the average. And then you also should be able to say, I can compare the mean and median of a distribution and choose the more appropriate measure of center in a given setting. Okay, now you're probably going, what does that mean? That's what our lesson's for. So at the end, you will know. So here's an example for measuring center. How long do people typically spend traveling to work? This is a huge topic right now, especially with gas prices. And so a lot of that has to do with where you live and also has to do with where you work. Okay, so here are travel times in minutes of 20 randomly chosen workers in the state of New York. Okay, and they turned around and they took this data and they put it in a dot plot. And so if I look at just the random numbers, I'm kind of like, ooh, I don't get anything. But now that it's on the dot plot, I'm like, okay, most of the people are spending between 20 and 30 minutes to travel to work. There is one person who's crazy, in my opinion, that's driving 95 minutes to work, an hour and a half. Whew. Yeah, what kind of job is that? And where does he live? Like, hour and a half is 3 hours of your day. But okay. Now, we can look at and say about 15 minutes is the most frequently occurring value because it has 4 dots. Okay. But this is not a good measure of center because it can fall anywhere in a distribution. Okay. So we're not going to sit there and say, oh, this is the one that's most often. It's not a good center. Now, we could report the value that's in the middle of the data as its center. That's the median. That's when we put the numbers in order from smallest to largest and we go, which one's dead center? Okay. So the median is going to be the midpoint. A little geometry here on you. Midpoint formula. And so this is the number that about half of the numbers fall in front of it and half fall above it. And in order to find the median, we've got to put the data values in order from smallest to largest. Again, your StatMatic does this for you. And here's a good rule of thumb. This is what I always do. If the number of values in your data set is odd, we're going to have a single number in the middle. So like, let's say it's 15. You have 15 numbers, okay? I always do 15 divided by 2. What do I get? I get 7.5. If it's a 0.5, I'm going to round it up to 8. That 8th value is the median. Now, if it's even, here's the problem. If it's even, instead of having one number in the middle is kind of split in between two numbers. So the middle, we got 6 on the right, 6 on the left. We're going to use 12. There's really not a number in the middle. And I always know this because I can go, okay, what is 12 divided by 2? I get a perfect 6. Okay. If it's even, I'm not going to have a single number. So if it's a 6, then that means I need to take the average of the 6th number and the 7th number. So if the 6th number was 5 and the 7th number was 6, my median would be 5.5 because that's the average of those two numbers. So if it's odd, you're going to have one number in the middle and one is odd. If it's even, you're going to have two numbers in the middle that you have to take the average of. And again, 2 is even, 1 is odd. So let's look here. They want us to find the median in this data set. First thing I'm going to do is I'm going to count how many there are. And I count, and there's 9. 9 is odd. And it's going off in my head. If it's odd, there's a single number that is in center. Okay, it's the median. Now, you can go to the applet and you can key all these in and it will arrange them in order for you. But this is a low data set, so I really can do this on my own. So I'm going to turn around and I'm going to put the numbers in order from smallest to largest. And you can see here. Now it's real easy to see my minimum number is 6, my maximum number is 40. So how do I know which number is in the center? And this is where I use my math formula. If there's 9 numbers, I'm going to do 9 divided by 2. What is that? 4.5. It's odd, so I'm supposed to get 1. 4.5 rounds up to 5. So that is going to be this number right here. Okay, count over 1, 2, 3, 4, 5. 21 is my median. Okay, this is the median. It's the number that falls in the middle of the data. Okay. Now, we would sit here and interpret this as saying because 21 is the median, about half of McDonald's fish and chicken sandwiches have more than 21 grams of fat, and there's about half of them that have less. Okay, because 21's right in the middle. Half have more than that, half have less. Okay, now let's go back to the New York question. Okay, we're going to find and interpret this median. And again, you can go into StatMatic, you can go under one variable quantitative data, and you can key in all these numbers. So for this first one here, you'd have 1 5, 2 10s, 4 15s, 3 20s, 1 25. You can key all those in. And then you do begin analysis, and it's going to spit the median out for you. Okay. Now, another way for me to do this is it says there's 20 here. 20 divided by 2 is what? 10. It's an even number, so it's the 10th and 11th number that I need to take the average of. So I can come here and I can count if I want to. Okay. So here is 1, 2, 3, 4, 5, 6, 7. So now I'm at 7, 8, 9, 10. So 10 falls right here. Here is 10. So that means this is the 11th dot. Okay. So 10 and 11. So I need to take the average of 20 and 25. And that's going to end up being what? 22.5. Yeah. Okay. Taking the middle, the average of 20 and 25. So I get 22.5 minutes. So that tells me that half of the data is going to be less than 22.5 minutes, and half of the data will be more than 22.5 minutes. Okay. Now, the most common measure of center is the mean, and mean is another word for average. Okay. This is another word for average. So when we have quantitative data, it's the average. And all you have to do is you're going to add up all the values and divide by the total number of numbers. So if you have 20 numbers, you're going to add all 20 of those numbers together and divide by 20. Now, again, can you put all those numbers in your StatMedic and run the analysis, and it's going to give you the median and the mean? And this is kind of what I touched on yesterday, where I said it's really a pain putting all those numbers in StatMedic. It really is. I get it. However, if you do it, now all of a sudden I have the median and the mean instead of me having to turn around and put all the numbers in order once, and then now I'm adding them all together and dividing by the number of numbers. So I'd get in the habit of using that StatMedic. Okay, because here's the formula for the mean. And yes, it looks crazy. I know that sigma's in there and x to the I, but all you're really doing is you're taking all the numbers, adding them together. And if you have 20 numbers, you're dividing by 20. If you had 9 numbers, you're dividing by 9. Okay, so let's look at this. Here we've got a baseball team, and they're wanting to know how many runs does the Lawrence High School baseball team usually score. So here are the data on the number of runs scored by the team in 21 games in a regular season. And not only are they giving us the numbers, but they're giving us a dot plot. And again, I can look at the dot plot and go, oh, yeah, it looks like there's an outlier at 12 runs. That must have been a really, really high scoring game. Okay. And so the data is nicely, I like this because it's nicely sorted from lowest to highest already for me. Okay. So A says calculate the mean number of runs scored during this season. So I can go into StatMedic, one variable quantitative, and I can key in all of these numbers. Remember, you got to separate them with a comma. Hit begin analysis, and it's going to give me my mean. Okay. The mean usually says mean, or it's listed as X bar. Okay. Now, the other way I can do it is I can go into my calculator app and I can add all these numbers together. And when I get the total, I'm going to take whatever that is and I'm going to divide it by 21 because there are 21 total terms here. And that's going to give me the mean. But again, I really don't want you to get in the habit of doing that. I want you to get in the habit of using the applet, because there's going to be other questions that come later that are easily answered because you use the applet. Okay. Now, part B. So A, there's the answer there. When we add all of them together and divide by 21, we get that they average about 4.14 runs per game. Okay. Now, B is talking about that outlier there, that 12 runs. So the dot plot suggests that, the game in which they scored 12 runs is a possible outlier. Can we calculate the mean number of runs scored per game by the team in the other 20 games of the season? So basically what they're saying is, this looks really unusual. Maybe they were playing a really, really bad team, and even their worst hitter was getting home runs. I mean, maybe they had a bad pitcher. Who knows? But we're saying this game, for some reason, was not typical. So we want to take it out of this mix. We want to get rid of this 12 and then see what our average runs are. Okay. And so now we are going to find the mean of this data. Here's where the applet can be really, really cool, because you've already keyed all these numbers in. Just go back up there and take out the very last one, the 12, and hit begin analysis again. Otherwise, now you got to go into your calculator app and add in all 20 of these numbers and divide by 20. And here's what's interesting. Look at the new average when we take out that 12 run outlier. They're averaging about 3.75 runs per game. That's a lot lower than the 4.1412. What if we turned around and we also now took out, so I'll change the color, this one? because both of those potential outliers. What if we took out both of those and we just figured out this data? That average runs per game would fall even lower. Okay. Because if you know anything about baseball, sometimes you get a team and you just their pitcher's not good or they can't field and you are scoring left and right. Yeah. Okay. This is why outliers can be a problem, because they can change and make things look better than what it is. Now, measuring center. Okay. That previous example illustrates an important weakness as mean as a measure of center. Okay. If we're just looking at the average, when there's an outlier, and I'll go back, when we had that outlier, it made it look a whole lot like the team was a whole lot better as far as runs per game. So sometimes mean can be a weakness when there are outliers. Okay. So here's a huge concept. The mean is not resistant. And what that means is it's not resistant to extreme values in a distribution. So if we have outliers, like something really extreme above or really extreme below, that mean is not going to be resistant and it's going to be affected. Okay. And that's important here. The median, the number that's in the middle, is resistant. Because we're taking the number in the middle, if there's some really way out there outlier above or below, it's not going to affect what the median is. But if you're taking the mean, it's going to be affected because you're averaging that number in. Makes sense. Okay. So if we look at this, if we go by the median number of runs scored is 3. Now remember, okay, if we remove the possible outlier in which they did 12 runs, what's the median still going to be? 3. So it's resistant. It didn't change. But remember when we did the mean, when we took out that 12, our average changed. It fell. Okay. So we're going to skip through. I know you're upset. So if we look again at that baseball team, okay, if we look at the dot plot and we include that 12, that outlier, the average number of runs is 14 runs. And here's this X bar that I've told you about. When you see this X bar, this stands for mean. Okay, X bar stands for mean. That's what's in your calculator. That's probably what's in StatMedic. That is just the standard symbol for mean. Little X, italicized X with the bar. So it was 4.4 runs. The median is 3. Okay. So which one should we use? We got to compare these. Do I use the mean? Do I use the median? Which one's going to be better? And so a lot of that is going to depend on the shape of the distribution and are there any outliers? So there's the two important things. What does the shape look like? And are there outliers? Okay. So let's go back and let's look at the dot plots here. Okay. So if we look, okay, these are two different ones. If we look at this first one over here on the left, okay, this is data that's skewed to the left. Okay, this is important right here. If it's pulled to the left, the mean will be less than the median. Okay, now to help you remember this is how I remember it. I'm going to go over here. Let me get a different color. Let's go purple. If I look at the 3 letters, MEA versus MED, if I'm alphabetizing this, mean comes first. So mean is going to be on the left, median's on the right. If it is skewed to the left, that means we're pulling it this way. Look at your inequality. It's pointing where? To the left. So skewed left, mean is less than the median. Same thing over here. If we're skewed to the right, mean is still alphabetized before median, but look at our inequality now. Where is it pointing? So if it's skewed right, our mean is going to be greater than our median. Okay. And so that's really, really important to know. So this right here, this is our baseball data. And that made sense. Our median was 3. Our mean score was 4.14. Okay. Now, here's one in the middle that is roughly symmetric. Let me see if I can erase all of these. Probably can't. So this one is roughly symmetric. So when you have roughly symmetric, look at what happens with your mean and your median. They're really close together. So it's kind of a toss-up. Like, which one do you want to use? Because when it looks roughly symmetric, your mean and your median are really going to be right there close with each other. Okay. But if it's skewed left, mean's going to be less than the median. If it's skewed right, mean's going to be greater than the median. Now, the whole point of this chapter, and we said this was one of our I can statements, you're going to be able to measure center and pick between the mean and the median. So how do we choose which one we want to do? Okay. If it's roughly symmetric, and there's no outliers, that's going to be where the mean and the median are really close together. We're going to choose the mean. So you can see that right here. We're going to use the mean. However, if it's one of those other ones where it's either skewed right or skewed left, or if it's symmetric and it has some outliers, we are going to use the what? The median. Symmetric, we're using the mean. But if it is strong, and again, here's a huge word here. Strongly skewed, not just slightly, strongly skewed, right or left, or it has outliers, we're going to use the median. Okay. So let's go back to our example on the traffic. Okay. So if I look at this data, it's not roughly symmetric. It looks like it is skewed to the right. We have somebody grabbing the bulk of the data and we're pulling some of it out to the right. Okay. So I'm looking at it. It's skewed right and it looks like there's an outlier here. We got one crazy dude that's like, yeah, sure, hour and 35 minutes to work there and back. No problem. Okay. Maybe this is round trip. I don't know. Even still, that's a lot. I'm assuming it's not round trip because one person's 5 minutes. Yeah. So if we look here, A is asking us, why is the mean so much more than the median? Well, our answer is the mean is not resistant. And because this is being pulled right skewed, it's being pulled in the direction to the right, the mean is going to be greater than the median. Also, you've got this possible outlier of 85 minutes. That is also going to inflate our mean. Okay. So the mean is affected, but the median, not so much. Okay. So that outlier is going to inflate that mean, but it's really not going to affect the median. So that's why it's higher. Okay. Now B, which measure of center better describes the typical travel time? This is that standard rule of thumb. If it's roughly symmetric with no outliers, we go with the mean. However, if it's right or left skewed or has outliers, we go with the medians. This is right skewed and it has an outlier, we're going with the median. So the average travel time, we would say the median travel time is about 22.5. Okay. And so I'm done. Aren't you excited? Yes. So again, now you should be able to say, I can find and interpret the median of a distribution of data. Use that StatMedic applet. You should be able now to say, yeah, I can go in StatMedic and I can calculate the mean of data. And then I can compare the mean and median. Is one greater than the other? Are they roughly together? And then also, which one am I going to use? If it's roughly symmetrical with no outliers, mean's our guy. However, if it's right, and again, that is not just slightly skewed. That is very, very strong skewed, right or left, or outliers, we go with median. All right. So I hope you enjoyed that. Don't miss me too bad. And I will see you in the morning. Have fun.